working with the identities is good in the sense that you might have to rearrange some things when you need to solve trig equations. This is going to be a two-part video. This is part one. We're only going to be working on simplifying using three different kind of methods. The first method is working with just a basic algebraic term. So what this means is up to this point we've worked with rearranging things and simplifying it so it's like cosecant x or tangent x or whatever that is. But in our case we're going to be working with this so we can figure out what x actually is. Okay? So for example, if I have 3 cosecant x equals 2 cosecant x plus the square root of 2. Okay, so what I'm going to do here is I'm going to try to get the variable by itself on one side and, you know, basic algebra principles here. So I'm going to subtract the 2 cosecant x from both sides. So I'm left with just a regular cosecant x equals the square root of 2. Now, this one's a little bit different. I've already got the x variable on one side by itself. Okay, great. Now, I need to use the unit circle in order to determine what x could potentially be. So your goal here with this is you're trying to figure out, based on the unit circle, what your radian degree measure could be. Okay, but remember, and this is where it kind of gets a little tricky, cosecant is really 1 over sine. So what I have here is if I'm going to relate this to sine, which I want to, because my unit circle is cosine and sine, I really have 1 over square root 2. Well, we know that we can't have a square root in the denominator, so we're going to multiply by the square root of 2 to the top and bottom, and I get square root 2 over 2. So how does this help me? This helps me because I now have sine x equals square root 2 over 2. So now I can use the unit circle in order to figure out what radian measures give me that square root 2 over 2. When I'm looking at the unit circle, remember that the square root of 2 over 2 is on the right of, so it's our y-coordinate. And we see that x has to be then pi over 4 or 3 pi over 4. But here's the thing. Yes, that is if you were just on the unit circle, but in the case that you are adding 2 pi on, because we know 2 pi is the full degree measure of a circle, your true answer is going to be x equals pi over 4 plus 2n pi. N represents the number of complete circles you have had. Or x equals 3 pi over 4 plus 2n pi. Okay, so that was just your basic algebraic problem. Even though it looks tricky, it's really not that bad. This next method, it's again, you're still solving it just like you would any other type of problem. It's just it looks a little bit more challenging. 2 equals 4 cosine squared x plus 1. This time we have our cosine squared, so we need to get that by itself. So looking at this, if this was any old problem, I would subtract that 1. I now have 1 equals 4 cosine squared of x. I need to get that cosine squared of x by itself, so I divide by 4. I have 1 over 4 equals cosine squared of x. I need to get rid of that square. So in order to get rid of that square, we got to take our square root. So when I take the square root of this, I get plus or minus 1 over 2. Now, when you take a square root, you're going to get the positive and the negative, which is what happened here. So now I need to go to the unit circle, and I'm going to have more options here because I'm plus or minus. I now can see, based on the unit circle, it's the left, x, there are 4 different options. Pi over 3, 2 pi over 3, 4 pi over 3, and last but not least, I have written down 5 pi over 3, but I want to double check that. It is in fact 5 pi over 3. But again, you need to consider, if you go a full rotation of 2 pi. So technically all of these are pi over 3 plus 2n pi. Or x equals 2 pi over 3 plus 2n pi, or x equals 4 pi over 3 plus 2n pi, or last but not least, x equals 5 pi over 3 plus 2n pi. Final answer. So again, still not bad. The biggest thing is making sure that you have your correct numbers based on your unit circle. Last but not least is when you have to factor. This is the third type of method. So for instance, if I had 4 cotangent x equals cotangent x sine squared of x. So looking at this, I have a cotangent x on both sides. So my goal here is to get rid of that. I'm going to divide by cotangent x because it's going to eliminate. I'm going to be left with 4 equals sine squared of x. I can't have that square root, or I can't have that square, so I need to square root it, so I get plus or minus 2 equals sine of x. Now, this one's kind of tricky, because when you're looking at this, technically on your unit circle, you never have a 2. So you need to think of it in terms of 1. Okay, so when does sine equal 1? Or negative 1 for that matter. And there are 2 instances where that happens. X could equal pi over 2 or 3 pi over 2. So what this is going to have me do then, I would then add on the 2n pi, depending on what the interval is that they give me. If they say that there is an interval that it has to lie between 0 and 2 pi, then this would be my answer. If they don't give me that interval, then I need to add that 2n pi on. We'll work more with this because there are other ways that you can solve, but these are the 3 basic ways, and I think they're probably a good place to start.